Okay, the first thing that you need to make sure you've done is put your name on the front of the packet and then 6 period. Okay? After you've done that, go ahead and turn to the first page. Today we're going to be talking about adding and subtracting polynomials. This is a review from 9th grade. I'm currently teaching my 9th graders to do this right now. Okay? So this should not be difficult for you. Also, we've kind of already done it this year when we added and subtracted complex numbers. It's just now we don't have i's, we have x's and p's and a's and whatever. Okay, so it's even easier because with complex numbers, sometimes when you combine i's, they become other things. With this, it's easier. Okay, so let's look at number 1. The same rule applies. Whenever it's subtraction, that minus sign belongs to everything in the parentheses that comes after it. So it belongs to the 3x and it belongs to the negative 2x to the 4th. It does not affect the x minus 2x to the 4th. Okay? It will make the 3x minus 3x and it will make the negative 2x to the 4th positive 2x to the 4th. Does everybody understand that? Now all you're going to do is combine like terms. This is a 1x, right? What could it be combined with? Negative 3x. So what is 1 minus 3? Negative 2. So you have negative 2x. Then you have a negative 2x to the 4th and a positive 2x to the 4th. Right. So this is your final answer, negative 2x. That's it. Okay, number 3. Same kind of problem. You're subtracting again, so you have to keep in mind that that subtraction sign distributes and attaches to the a to the 4th, making it minus a to the 4th. And when you distribute it to the negative 5, it makes it a positive 5. Okay, it does not affect the binomial in the front. It remains 4 minus 4a to the 4th. Now that you have simplified the signs, we can start combining like terms. What can you combine with this 4? A 5. What is 4 plus 5? 9. And then what can you combine with this negative 4a to the 4th? Negative 1a to the 4th, right? And that is negative 5a to the 4th. Now, I don't want you leaving the final answer like that because it's not in standard form. Standard form means that the exponents need to go from the greatest to the smallest. So in this scenario, you only have one exponent, so it's obviously the biggest. It's the only one. So it would go first, and then that positive 9 would go last. Now the answer's in standard form, so that's your final answer. With the number 1, we didn't have to worry about standard form because there was only one term, period, so you wouldn't be rearranging anything when there's only one term. Okay, number 5. This one's actually even easier because it's addition, so you're not going to have to worry about distributing any signs. You just start combining. What can combine with the 3x? 5x. So what's 3x plus 5x? 8x. And then you can combine the negative 2x squared with the nothing, right? There's no other x squared term up there, so you just bring it down. And then the only other term is the negative 2x to the 4th, and it just comes down. Okay, so that's the final answer, but is that in standard form?
No.
No. What do I mean by standard form? The highest what goes first? Number what though? Exponent. Okay, your highest exponent goes first, and then you just work your way down. So in that case, which term would come first? Right, then, and then the positive 8x. And so that would be the final answer. Okay, why don't you go ahead and take a second and try number 7 by yourself. Okay, number 7. Since it's addition, we're not going to have to worry about any signs changing. We're just ready to go straight into combining like terms. What can be combined with the negative 13 into the 5th? Okay, so what's a negative 13 plus 12? Negative 1, right? Do you have to write the negative 1? Correct. You have to write the negative, but you don't have to write the 1. It's understood. Then we move on to negative 13 into the 4th, which can be combined with what? that makes negative 19n. Is that in standard form? Yep. Yes. Okay, let's look at number 9. What do I have to do first on number 9? Correct. Distribute the negative. No, we didn't. Okay? That does not affect this first trinomial. Okay? It stays negative 4 plus 3a plus 11a squared. But over here, it'll attach to that 12 and make it minus 12a squared. When the minus attaches to the minus 6, it becomes positive 6. And when it attaches to the negative 13a, it becomes positive 13a. Any questions? Okay, now we're ready to combine like terms. So, negative 4 can combine with positive 6 and make a positive 2, right? So, and don't you already know positive 2 is a constant and all constants go at the end when you're writing them in standard form? So you can kind of start writing them in standard form as you go. Okay, then 3a combines with to make 16a. And remember, the 2 was positive and the 16 was positive. Okay, now I can combine 11a squared with negative 12a squared, which is a right. Is that in standard form? Okay, go ahead and try number 11. What's the very first step that we need to do? Right, distribute. Which one are we on, 11? Okay, distribute the negative to everything inside the parentheses that comes after the negative. So that does not affect this first polynomial. Okay, but it makes the a to the 4th minus a to the 4th. It makes 6a minus 6a, then minus 1, then minus a squared. Now you would just start combining your like terms. Negative 8a squared can combine with negative 1a squared to make negative 9a squared. 6a cubed is the only one of its kind, and it's going to come in the front of the a squared term, right? Negative 6a can combine with the other negative 6a to make a negative 12a. Negative 3 and negative 1 combine to negative 4. And then negative a to the 4th is the only power of 4. And it's the highest degree, so it comes up front. And then you need a connection there. What sign was the 6? Plus. Is that what you got? Okay, number 13. This one's even easier because you don't have to worry about signs. You just start right away combining like terms. What can combine with the negative 4k cubed? We're doing odds. 3k cubed, right? And that makes a negative 1k cubed, right? Then 2k squared can combine with k squared, which is how many k squares? Positive 3, right? And then 3k combines with negative 8k, which makes negative 5k. Negative k to the 4th, that's the only term up there that's to the 4th power, and that's the highest degree, so it will come in the front. And then the only constant up there is this positive a, and constants always go at the end. Okay, go ahead and turn to the next page. I'm going to show you something I did. You know how like this one's not affected by the minus sign, so I just have to bring it down each time? Well, I decided to save myself some time at the end. I went ahead, when I rewrote it down here, what did I do? I rewrote it in order in standard form. And that way, once I actually do it all, it'll end up in standard form. Okay, now, this minus attaches to everything that comes after it inside those parentheses. So, like, it'll make this negative 3b to the 4th positive 3b to the 4th. It'll make this negative 3b cubed positive 3b cubed. This will become negative 4b, and this will become negative 4. Now I'm ready to combine like terms. 7b to the 4th combines with 3b to the 4th to make, right, and then negative 1b cubed will combine with 3b cubed to make 2b cubed. And then 8b squared will combine with minus 4b is 2b, and then all I'm left with is negative 4. And see how once I rearranged this in order when I brought it down, it went ahead and now it's in standard form when I answer it. I don't have to take the time to put it in standard form. Okay, number 17. The only difference here is that you're subtracting three different things. You have a trinomial minus a binomial. The same rules apply. This negative will distribute to everything inside these parentheses. Okay, and this negative will distribute to those two terms. So just like always, it does not affect this first trinomial. Since I'm going to have to just simply rewrite that, why don't I go ahead and put it in standard form while doing so, and that way at the end my answer will automatically be in standard form. So when I rewrite this trinomial in standard form, what term comes first? Right, then, and then, right. Okay, so I rewrote that one, but when I did so, I put it in standard form. Now I need to attach this negative, stop talking is rude, to everything that comes after the negative sign. So this 11 will become minus 11 r to the fifth. And then minus 2, and then minus 10 r to the fourth. This minus will make that 5 minus 5 r to the fifth, and it will make that negative 11 positive 11 r squared. Now I'm ready to combine like terms. I have an r to the fifth starting out. What will combine with it? So what's negative 13 minus 11? Negative 24 r to the fifth, right? Then I move to my next highest term, negative 10 r to the fourth. What will it combine with? To make, negative 10 minus 10? Oh, I see what you're saying. There's a third one. Also a negative 5 r to the fourth. And what they all three combine to? Right. Okay, then I move to, okay, look, now they're a little out of order. If you look across, we've got an 8 left, a negative 2 left, and an 11 r squared. Shouldn't we go ahead and do this one next so it'll stay in standard form? But it just comes down because there were no other r squares, and then you can combine your constants. 8 minus 2 is positive 6. Okay, you go ahead and try number 19. 13 n to the fifth. Okay, are those the only n to the fifth terms? What do they combine to be? Right, negative 9 n to the fifth. Okay, then moving on. 10 n to the fourth can combine with, but remember it's negative. So 10 plus 3 is 13, but 13 minus 12 is, so 1 n to the fourth, so plus n to the fourth. Okay, then we have negative 12 n cubed and positive 9 n cubed, which is a negative 3 n cubed. And then all we're left with is this negative 6 n, and is it in standard form? Yep. Okay, we're going to skip 21 for today because we're going to do like a separate little lesson on what it means for a polynomial to be closed. Okay, so we'll skip it for today. Let's look at 23, and then once I do 23, you should be able to figure out 22 when you're doing the evens. Okay, here we go. One of the sides of a triangle is 4x minus 6. Okay, so I'm going to label this side of the triangle 4x minus 6. I know, draw yourself a little triangle first. Okay, another side of the triangle is x squared plus 7. Shh, I'm almost finished. Pay attention. If the perimeter, which is P, equals x squared plus 7x plus 5, find the missing side. So this side is unknown. And even though, yes, my triangle looks equilateral, we don't know for sure that it is. Okay? We know this side equals this side equals this side is unknown, but they did give us the perimeter. Well, how is it that you find the perimeter of a triangle? How is it you find the perimeter of any figure? Add all the sides, right? So first let's add the two sides that we know. Okay, when we start adding up the two sides that we know, 4x minus 6 and x squared plus 7, what can be combined out of those four terms? Okay, so like the x squared can't be combined because it comes first, right? 4x can't be combined, so it'll come second. But then the negative 6 plus 7 becomes a plus 1. Well, don't we see what we need to add to that, the missing side, to get a perimeter of x squared plus 7x plus 5? Is everybody understanding what I'm doing? Okay, I added these two together. Those are the first two sides. But to find the perimeter of a triangle, I need to add all three sides. So I need to know what the two sides added together plus the missing side will total up to. Well, to get x squared to become x squared, what do you need to do? Leave it. It's already x squared. To get a 4x to become a 7x, you need to make it you need to add 3x. And to get a 1 to become a 5, you need to add 4. So that means the missing side is 3x plus 4. Does that make sense? Okay, you need to be working on the evens for classwork until I say switch out. Whatever you don't finish is your homework.